A lot of you are getting it right, but you're writing things that are mathematically wrong. We can't have that. So the way we do this is we need to rearrange it into standard form. That looks fairly good. So we have 2x squared plus x minus 10 is equal to 0. And at this point, we're going to try and factor it. Because the coefficient of the x squared term is not equal to 1, then we need to do that extra sort of trick to factor it. And that's why you're writing things that are wrong. Looking on your work, what I've seen most happen is this. People write that. That is wrong. You cannot get from that blue equation to that red equation. There's no mathematical operation. Those aren't the same equation. Let me show you. That it's wrong. Okay, so what we're looking for this is we're looking for the roots of this function, y equals 2x squared plus x minus 10. So if we were to, this isn't actually a function, but it should have the same roots as this function here. So if we write 2x squared plus x minus 10, plus x. So we can see that the roots are going to be minus 2.5 and 2, and that's what the equation gives us, and that's what we should be getting. This second equation that a few of you are writing, y equals x squared plus 10x minus 20. Oh, sorry. Okay. If we look at the graphs here, we're only interested in the roots. Do they have the same roots? So then it's not the same equation, or it's not an equivalent equation. You can't go from that equation to that equation because they're not the same thing. They would have the same roots. Now, sometimes you can take an equation like this and you can multiply by 2 or something. So if I was to multiply it by 2, watch how, even though the function's different, I'll get the same roots. Y equals this. So this would be plus 2x minus 20. Oh, sorry. Okay, notice, let me just switch that one off, how these ones have the same roots because they are equivalent equations. I haven't changed what the unknown variable x is. I just simply multiplied through by 2. So if I was to change any of the constants here, I have to change everything together with it. So this, what you're writing, although it's leading you to the correct answer, is bad mathematics, and you can't have that. So let me show you how we should structure this. Basically, very, very similar to what you're doing, but your math has to be correct. Sorry, so normally we would look at the product at the end here of this term, the minus 10, and say what are the factors of minus 10 that add together to give that number in the middle. But when we have this, we need to sort of generate some other number. So we take a times c, which is equal to negative 20, and then we ask ourselves, what are the factors of negative 20, which will add together to give this sum term here in the middle. So we can see that if we take 5 times minus 4, it will equal minus 20, and 5 plus minus 4 will equal 1, which will give us this, and it will give us this. Okay, and that is our clue that we can take forward now. So what we should do is we take our two factors like this one, we take this expression, and we're going to separate this 1x into 5x minus 4x. Because 5x minus 4x and 1x are the same. We have to decide, should we put the 5 with the 2, or should we put the 5 with the 10? And It will work both ways, but usually it's a bit easier if you see common factors. So for instance, 5 and 10 are going to go together, 4 and 2 will go together, and that'll make my job a little bit easier. So I'll do minus 4x plus 5x minus 10 is equal to 0. At this point, this is still the same equation as the one above. I haven't messed with it at that point. I haven't messed with it. So what I'm going to do now is I'm going to factor the first two terms and the second two terms. From the first two terms, they have a common factor of 2x. So I can take out 2x from both. If I take 2x out from 2x squared, I get x. If I take 2x out from minus 4x, I get minus 2. Next, I'm going to try and factor the second one to produce that same kind of a bracket. At this point, I saw in a couple of people's paper, they had a product there, and it's not a product, because now I'm just going to be factoring this. So this plus sign stays there, and then I factor this. So I can see that if I want to factor out the 5, I'm going to get x minus 2 is equal to 0. This equation has 3 terms. Terms are separated by a plus, a minus, or an equals. There's this first term, 2x, x minus 2, that's one term. The second term, 5 bracket x minus 2 is the second term. The third term is 0. It's on the right-hand side. The first two terms have a common factor. What is the common factor to the first two terms? X minus 2. So what I'm doing at this point is I'm factoring out the x minus 2 from those two terms. That would leave me with 2x plus 5 is equal to 0. At this point, I've got it into factor form, and I can use the null product theorem. So at this point, by the null product theorem, we can say that either, in order to get the product of two numbers, so the null product theorem you should be familiar with, that the idea of the product of two or more factors is equal to 0, it means one or more of those factors must also be 0. So the null product theorem tells us that x minus 2 is equal to 0, or 2x plus 5 is equal to 0. This will give us the solution x is equal to 2, and x is equal to minus 5 over 2, which we saw on the graph. It is not just important that you get these answers. Your mathematics must not be wrong. It must be correct. So take a little bit of care. The most common thing I saw is people, you start with an equation. If you switch to an expression, how have you got an expression from an equation, and how can an expression ever have any solutions? An expression can't have solutions. Only an equation can have solutions. An expression has a variable. This doesn't. This just has an unknown. X is an unknown. It's not a variable. It's an unknown. As long as your mathematics is written correctly, I'm seeing some mistakes in the mathematical language. So the slip and sign method is a variation on this, and sometimes there's some sloppy mathematics in it, which is okay for, it's not really okay for advanced students. Okay. So there's some to practice on that one. That was the easy bit that was supposed to be revision. Make sure you tidy up your mathematics a little bit. This bit we're going to solve by completing the square. It became aware to me during the teaching this week that you didn't do this in IM3. You must have skipped it along with many other things. So we need to solve this by completing the square. This is a very useful technique. You can rearrange it in a few different ways, but basically, let's take the equation like this. I'll do everything the same way. We've got 12x. Let's pop that to the other side for now. Pop that over there. This works on that technique that we looked at yesterday, which is derived from the expansion of a plus b squared is equal to a squared plus 2ab plus b squared. So we use this formula for the quadratic expansion to help us. And what we're going to do is we're going to try and factor the left-hand side of the equation into an a plus b squared. So, yes?
Isn't it that you take the magic number, which is b, and then you divide it by 2?
Yep.
and then you factor it, and then you subtract that after.
Yeah, b squared. So we're going to be focusing on this term here. We're going to focus on this term here, 12x. 12x is going to be this term here. It's going to be this term here. So it's 2 times a, which is x, and then b, which is 12. Well, we have to find b, sorry. So if 2ab is 12x, then b has to be 6. So we're going to go for an x plus 6 squared. Unfortunately, x plus 6, when expanding, will give us x squared plus 12x plus 36. So we've added 36 to the equation. So we have to keep it balancing, so we take it away. Like this. That's it. This is the most effective way to solve quadratic equations. It is the easiest way to solve quadratic. No. It is the way that to solve quadratic equations that works for every quadratic equation. The techniques that we've been looking at, the simple technique when the coefficient of x squared is equal to 1 will only work if it's integer values. The technique we just did will only work if it's rational numbers. Rational numbers being in the form of a fraction a over b, where a and b are integer. This will work for irrational ones as well. This is the one that you use to prove the quadratic formula, and to prove the other methods work. So this is the base one. So what we can do now, we can solve. And if we add 36 to both sides, we get x plus 6 squared. If we add 36 to that, we're left with 9. So now we take the square root of both sides. When we take the square root of that, we're going to get plus minus 3. And then we can subtract 6 across. So these are our solutions. And then we can state the two solutions. This implies that x1 is equal to minus 9. x2 is equal to minus 3. I'll just give you a minute. So whatever this number is, this 12 here, we halve it and we put it inside the bracket. What we take away is that number squared. It comes from this expansion. A plus b squared is a squared plus 2ab plus b squared. So we have to take away b squared. And we find b by halving whatever is there.
So what if the 12 is
And then we have minus.
Minus 6.
There's not a lot of difference in the expansion of this one. It gives us a squared minus 2ab, but it's still plus b squared. So we still take away b squared. Okay, that's an easy one. Let's try a slightly harder one. So we're going to solve this one by completing the square. Are we ready to move on? Yes. Anyone not ready to move on yet? Okay. So we've got 2x squared plus x is equal to 7. What is the value of b? 1. What is a half of that? Don't use decimals. Much easier to do this working in fractions. So that's a half. But I've got this 2 at the front. I've got this 2 at the front. How do I, if I have a 2 there, that will give me a 4. So there's a few ways to handle this. You can factor it out, but I would suggest just dividing through by 2. You can get, once you get more, this is the easiest way, you're just equation solving. If you're having to factor without changing the expression, then you're gonna, it gets a little bit trickier. But let's go for the basic way. I'm just going to divide through by 2. So that will give me x squared plus x over 2 is equal to 7 over 2. Don't use decimals. Much easier to use fractions. Get used to it. So what is b now? What's a half of that? So this is going to be 1/4. So if you're halving something, you're just multiplying the denominator by 2. If you're quartering something, you multiply the denominator by 4. So we've got this. So we need to remove b squared. We need to remove b squared. What's that going to be? So 1/16, 7/2.
So I think I've got the 1/4.
Half of a half.
Because in 280, yeah.
So x plus a quarter square is going to be 57/16.
Wait, yeah, so by the way, since it's 2AB, isn't it 2/2? Why are we multiplying the denominator?
Because what? We always halve it.
Oh,
So this number 12 here, we halve it, we get 6. So as a fraction, it's 12/2. We just put 2 in the denominator. Whatever the denominator is, increase it by 2, by factor of 2. So 12/2 simplifies to 6. Here we have the fraction 1/2, so 1/4.
so how do you know the x is what?
Sorry?
How do you know the x is? Oh, okay, no, I get it. Sorry.
So now we need to take the square root of this. It gives us x plus a quarter is equal to plus minus root 57. That's not going to simplify, but that one will. Over 4. So x is equal to minus 1 plus and minus root 57 all over 4. And if you're familiar with the quadratic formula, you'll see that that's fairly similar to how the quadratic formula solutions work. This is because it comes from this method.
When you expand it.
So 1/4 squared is 1 squared over 4 squared, 1/16. Likewise, when I did the square root of 57/16, it's the square root of 57 over the square root of 16. It's the same exponent law. The same exponent law in both of those. You this one here in exponent form with a bracket is 57/16 to the half.
Hey, so, why did you do 57 divided by 4? Why did you change it from 16?
A square root. A square root.
Oh, okay.
Yeah.
So for that, you get -1 plus or minus 7.
I've got a quarter here. I have to subtract a quarter from both sides. And they have the same denominator. So so it's minus 1/4. So that number at the front is minus 1/4, and this is plus minus 57, root 57/4.
Are you required to simplify the radical, or
You should simplify the radical if it simplifies, but I don't think that one does. You should simplify your radical.
you don't need some square roots? Like, if you can simplify the radical, we always should.
You should always simplify the radical. So, particularly, don't write root 49. That's 7. But even something like root 20, it needs to be written as 2 root 5. How long should I wait?
What is root?
How long should I wait?
Root 57/10 is equal to Oh, 57.
This is a 6.
No, the one that's above. Yeah, but
So I was asked to explain how I get from this to this.
oh, and then you just.
And I was explaining it. So root 57 over 16. Root 57 over 16 looks like this. Sorry, my 6 is a bit sloppy. And it separates, and because the root 16 simplifies, we simplify it.
So, this x plus 1 over 4, where did the 1 over 4 go in the last step?
I just subtracted a quarter from both sides. Okay. Like I said, I'm going to move on with this one now. I'm recording this so you can watch it through if it goes a little bit too quick for you. You can follow the algebra through. So we're going to solve inequalities next. Quadratic inequalities. So if you remember from your inequality algebra, you have seen inequality algebra. Yeah. So what is the main difference with inequality algebra? Because you can add and subtract values from each side, but what's the special rule you have to remember? I'll take you in a second, but I just want a few hands in the air. What rules do you have to remember about inequality algebra? At the back.
Pretty sure when you're dividing or multiplying a negative number, you switch the sign.
Perfect. So like with equations, you can add numbers to both sides, you can divide and multiply on both sides and so on. But if you multiply or divide by a negative, you have to flip the sign in the opposite direction. What happens when you take a square root of both sides? That's what we're looking at now. So here's an easy example. We've got this inequality here, 5x squared can be rearranged to is less than 75. I can divide both sides by 5. X squared is less than 25. Now, with an equation, what would I do next? At the back.
Take the square root of both sides.
What I have to remember when taking the square root of both sides of an equation?
Have to equalize before taking the square root.
Is this only for inequality?
No, with equations. If we take a square root of both sides of an equation, what do you have to remember to do?
Yeah.
75 divided by 5 is 50.
Oh, okay, sorry. I'm with you.
75 divided by 5.
Yeah. Let me cheat then. Okay, it's going to divide by 3 on both sides. I want a square now. Okay. When we divide both sides when we square root both sides, what do we have to remember to do? We have to remember, I've already done it. Here at this point, I square root both sides. So the operation that got me from here to here is me square rooting. I didn't just square root, I added something extra. The plus minus. We have to remember when square rooting both sides of the equation that there could be 2 possible solutions. Not that there could be 2, plus and minus. It's worse when we square on both sides. We have to remember that we can introduce a whole solution. But we're not there yet. So-
it's still less than or like the sign still be less than?
No.
So what?
No. Wait. What's happening when I square root on both sides? I can't do this. I can't say x is less than plus minus 5. That doesn't work. Let's have a look at it from a graphical perspective. So the left-hand side of this inequality is the function y equals x squared. The right-hand side of this inequality is the line y equals 25. We want to know These points here at intersection are quite easy to find. So this point there is at minus 5, 25, and this point here is at 5, 25. So the coordinates of these points we know, don't we? This is minus 5, 25, 5, 25. Which solutions do we want here? Which x values, when squared, will be less than 25? No, there's more than one solution. There's an infinite solution.
Like one of them has like one side going like the sign one way, the other one has it the other way. But if
No.
you're not,
Not quite.
so the x is.
But what
less
numbers, I'm not looking for the answer to my inequality yet, I'm asking for what numbers, when squared, are still less than 25. You can see it here in this graph. See?
The value of x between minus 5 and 5.
Yeah. So all of the numbers along that part of the number line, when squared, will still be less than 25. This is what this graph shows us. So we need to describe that. So we can't describe it like this. This is wrong. Let me take that off now. We need minus 5 is less than x is less than 5. That's the solution. That's how we square root an inequality. When you're doing an inequality which is fine, this is a finite inequality because it's between two bounds, they always point left. People get all sorts of crazy confused with inequality symbols. These inequality symbols always point left with a finite inequality. They can't point in different directions, that makes no sense. I shall pause there for a minute. When we multiply or divide by a negative. Or when x is on the right hand side and we want it to be on the left hand side, and we just rotate the whole thing. Okay, let's go a little harder. Let's solve this inequality. So, how can we solve this one? There's a couple of techniques on this one. I'm going to choose, I was looking at this number here. I was just looking at it. I can choose to use completing the square to do it, or I can choose to factor it. Looking at that one factors quite easy, and it doesn't complete the square so easy because 3 divided by 2 is annoying. The 4 will look nice and very tempting, but it's not. So what I'm going to do for this one is I'm going to choose, so my first stare at the problem is me choosing which strategy I'm going to use. So I can use any quadratic equation solving strategy to assist me in this one. Either completing the square or factoring are the best two. So I'm going to factor this. That factors easy. How can we factor the left-hand side of the inequality?
So
Is it Timur?
yeah.
One name learned.
So you would do as brackets x minus 4 and then brackets x plus 1.
Okay, we got x minus 4, x plus 1 is greater or equal to 0. So we need to decide, it's either gonna, we've got two choices now. We've got two choices. We know our solution is going to be from here at 4, here at -1. We've got two possibilities. The solution will either be here, or the solution will either be here. Either between those two or outside of those. And if you don't have a lot of experience with these yet, you will develop this experience. But one simple technique and strategy to answer that question is a sign table. So if I take some x values, if I put -4 into the left-hand side, what will I get?
The right answer.
If I put 4 into this, into the left-hand side, what will I get? 0. That's why we have it, so it's minus 4 is 1 and minus 1 and 4. So this is 0 and this is 0 because that's why we factored it. Pick a number in between.
0.
Sorry, can you open your eyes or leave my classroom? Sit up straight, look to my script, you're paying attention. Come to school with better sleep. We can choose any number between these two to test it numerically. The easiest number to test anything is 0. 1's a great number. That's another great number. Massive numbers are easy to check things as well. So let's take, for instance, in this one, 0. If I put 0 in there, what I'll get, I don't even need to, I'm not interested in what answer it is, so I don't have to do the arithmetic. I'm only interested in the sign. If I put 0 into the first bracket, will that be positive or negative?
Negative.
It will be negative. If I put 0 into the second one, will it be positive or negative? Will the result be positive or negative?
Negative.
Are negative numbers less than 0 or greater than 0? So this is negative. So we want the left-hand side to be positive or negative?
Positive.
Positive. So which one of the answers is it?
Less than -5 and more than 4.
The red or the blue one?
Right.
Red.
The red one. You could test it with another number. Let's say we put in 5. Let's say we put in 5 here. Would this be positive or negative?
Positive.
If we put in 5 here, would it be positive or negative? Will the result be positive or negative? So I'm not actually doing the arithmetic. I'm just going, all right, negative, positive, that's fine. And that will help me answer this quite easily and quickly. So, what is the solution to this one? I need to describe it here, these red ones. To describe these red ones, we can't do it in a single inequality. We have to do it in two. So this one over here is x is less than or equal to -1, or,
X is greater than
and that's my answer.
So it's just like on the ground, but on the outside.
Yeah. I'm just pausing so that you absorb and get your breath back. Okay, we ready? How far? How far?
A little bit further.
Well, it's better. This is our last one. Yeah. All right. Determine the value of n so that the equation 2x squared minus nx plus 18 equals 0. Determine it so that this has no real roots. Explain to the person next to you what this gibberish means. What this question means. We've never looked at a function yet. There are no functions. Equations. Our understanding of the meaning of the equation. So if you use a graph as a function, it wouldn't just say a graph. No. Not the right answer. The D. Not quite. Yes. Team one got that. Okay, how are we doing over here? What are you giving me? Come on. The sign check. If we want this, you think it's 0. You need to actually follow it. So we took a value in between, like 0, so it's negative. And then we took a value here, so it's positive. You can test that one as well, show that one's positive. So bigger than 0 is positive.
So we have two options.
Yeah, and then it's
So to give them yes, you're right. It's good. It's a good thought. I'm just going to correct you. Not perfect. Doesn't it? It's an equation. However, if you look drastically at you don't graph this equation. If you graph an inequality, it's great. So that's nonetheless really clear. One dimension. No, I use
Yeah, but how do we no, I don't. So
Okay. All right, let's have a look at our solution here. What does no real roots imply? What does no real roots imply?
The discriminant is it like less than 0 or it's equal to 0? Less than 0.
It implies that the discriminant is less than 0. If you remember from last year, hopefully, if the discriminant is less than 0, you've got no real roots. If the discriminant is equal to 0, you've got two real and equal roots. If the discriminant is greater than 0, you've got two real and different roots. And looking at graph perspective of that, it doesn't touch the x-axis when it's no real roots. It touches the vertex on the x-axis when there's one root. It touches below the x-axis, making two real and different roots.
Wait, so you said when the discriminant is bigger than 0, you have two solutions, and when it's equal to 0, isn't it one solution?
One solution to equation, conceptually from a function's perspective, you have two real but equal roots.
Okay.
Yeah.
So it's like plus or minus.
No, it's x1 is equal to 2, x2 is equal to 2. But from an equation perspective, it's one solution to the equation. From a function's perspective, you always have two roots. They're either for a quadratic function, you always have two roots. They're real and different, real and equal, or two non-real ones. We will find the non-real ones this year.
So what is the discriminant?
The discriminant, so this would imply that b squared minus 4ac is less than 0. So that's the discriminant formula. We can put in our numbers now. So what is the value of b? No. Negative n. So this gives us negative n squared minus 4. What's the value of a?
2.
What's the value of b? Oh, sorry, c I meant to say.
It's negative minus n.
So we get this. What is 2 times 18 times 4? 4? That's
144.
144. 144.
It's negative 144.
Yeah, negative 1.
Yeah.
So this will give us n squared is less than 144. What's the solution to this equation? Inequality.
N is more than negative 12 and less than 12.
Can you give it as a single inequality?
So 12 less than x less than negative 12.
No.
Vice versa. Negative 12 less,
So
less than negative.
start by saying that number, negative 12, less than n, less than 12.
So that's it.
Yep. I added it to the other side. If this is negative, then this is what, if I move it to the side and it's still negative, no, there would be no possible way to make this happen. No solution. There is no such end that there is no, that's possible, so type of solving.
Just to know, like, when.
Hold on, let me say at this particular point, we're finished there. There is a worksheet for you to practice on this one. And I'm just going to stop my recording.
Is there ISO?
I didn't assign any IXL for this one.